Now I realize that you guys know what polygons are. Just basically a many-sided figure is all it is. So it's not that big of a deal. You just got to remember that they're always going to be made up of segments, line segments. It's not a polygon. If it's got any type of curve in it, it is not a polygon. Now, when you take a look at the ones down below there, you got a circle, you've got a half a circle, you've got four lines connected to each other, but they don't close, so it's not a polygon. And the next thing is a three-dimensional object. So those are not polygons. Well, yeah, you can just use a ruler to draw a polygon. Straight edge. Yeah. Yeah. So, and we've got some words, sides and vertex. Well, vertex is just simply going to be a corner where two sides meet, and the sides are just going to be sides. So, now, these are things that you should make sure that you have down. Equiangular polygon is a polygon in which all angles are congruent. Equilateral polygon is where all sides are congruent. And if a polygon is both equiangular and equilateral, it's called regular. If a polygon is not equiangular and equilateral, it's irregular. So basically, it comes down, everything is an irregular polygon unless all the angles are equal and all of the sides are equal. If they are like that, then you've got them. So when I take a look at A there, A would be considered a regular polygon. It's got 6 sides to it. All sides are equal by the little marks, and all of the angles are equal. Now B looks like it could be all the angles are the same, but the sides are of different lengths. And the reason I know they're different lengths is because they're not the same. C, they're all the same, but the angles could be all different. I don't know. And D is just whatever because it's just got 6 sides connected. So, I'll give you a few moments to finish putting it down. Okay, moving on. Now, there are going to be some polygons that we are going to identify by name. Okay? So I've got them written down here. Triangle, quadrilateral, pentagon, hexagon, heptagon. And yes, you should pretty much have those and know what those are because those words will come up quite often. So, anybody need time to write it down? And really just the word and the side and what are the number of sides. It's really all that's necessary. So, here are the next ones. Ready? Ready? Here are the rest of them. Nonagon, yeah. And no, that doesn't mean that it doesn't have any sides. Nonagon just simply means that it's fine. For which one? but that's octo, not octa. Difference. It's not named for 8 sides. All right, here we go. So, if I'm going to classify these, I need to determine whether it's equiangular, equilateral, regular, irregular, or more than one of these. So, it's fairly easy, right? If I take a look at A, what does A only appear to be? Equiangular, okay? Well, did you read the instructions? Determine whether it is equiangular, equilateral, regular, irregular, or more than one of these. And that's, some of you just, you look at it and think you know what the answer is. Read the instructions. It's unfortunate that you guys keep getting things wrong because of that. So, this would be equiangular. Okay, if you just want to do it like that for right now. Is it anything else? Irregular. Okay. What about B? What is that one? Okay, so we got equilateral there. And would it be anything else? Would it also be irregular? Because for it to be a regular polygon, it has to have both of them, correct? So, what about C? What would that be? Just irregular. Because I don't know if the sides are the same or the angles are the same. What about D? What would that be? Okay, so we got equiangular again. Irregular. Well, doesn't it look like a square? Isn't it a square? It looks like a square, but I don't have the sides identified, right? At best, I know it's a rectangle, but that's it. It could very well be one of those as well. So, let's take a look at this. Diagonals of a polygon. Now, a diagonal is something that connects two non-consecutive vertices. Is A next to C? Does A go to B? Yep, consecutive. Does A go to E? Yep, consecutive. Does A go to D? No, it's going to be a diagonal. It has to go across the center. Okay? So, diagonals can help us determine whether it's going to be a convex or a concave polygon. If I can draw a diagonal across the polygon from any angle, or I should say any vertex to any other non-adjacent vertex, without it crossing a line, I got a convex polygon. But the other one that's concave, if you take a look at it right down here, it ends up going across line. Okay? So that means it is not convex, it is concave. So I would definitely make sure that you have it written down so that you know what a convex and a concave polygon look like. Okay? Be a very, very good idea to have. Well, you don't have to draw the shape exactly. You just got to give yourself an idea of what it is. All right. Ready to continue on? All right. So, it says find a diagonal that contains points in the exterior of polygon ABC. What would have to be exterior? What does it mean by exterior?
Outside.
Ah, good. So if I wanted to draw a diagonal on the outside, which one would it have to go from and to for polygon ABCD? B to D, or D to B, either way. So, is polygon EFGH, is that convex or concave? If I draw a line from any vertex to a non-adjacent vertex, do I go inside or outside? Both, but if I go outside, that means it cannot be, so it has to be what? Concave is going on the outside, convex is on the inside. That's why I told you to draw the picture so that you've got an idea in your mind so you know which one is which. Now my question for you is, are these two polygons congruent? Are corresponding sides congruent? Are corresponding angles congruent? So if corresponding, well, C is the same as H, right? B is supposed to be the same as G. 1 and 2 connect to B, 1 and 2 connect to G. A and F appear to be the same. 3 and 2, yeah, looks. But by the marks, that tells us exactly, correct? So, next one. Interior angles and exterior angles. Just like what they sound. Interior means it's on the inside. Exterior means it's on the outside. Okay? So, we have some theories or theorems that are going to be working with that work with the exterior and interior polygons, or angles, so we need to make sure that we identify which ones are which. So, it's a shape of some kind. What is angle 1? Is it an exterior or an interior? Appears to be outside the shape, so it's got to be exterior. Is 2 interior? Is 4 interior? Okay. Give me a moment. So, 4 was on the interior, correct? What's 3? Exterior. And you're sure 2 is on the interior? Why? Just because I put the 2 inside doesn't mean that it's on the inside. The circle part is on the inside, therefore it's on the inside. Okay. Now, got a floor tile there. What kind of polygons are in there? Well, yeah, quadrilateral's got 4 sides, right? And hexagon has 6. But is that a hexagon in there? Octagon has 8. Are they regular or irregular? Why? Yeah. Otherwise, it really wouldn't fit the pattern, would it? Well, if you take a look down here, this angle, this angle, this angle are all the same, right? That side is in there as well, that side. So all of these, all the sides are the same, all the angles are the same. Therefore, they would both have to be regular. Okay? So, are all of the octagons congruent?
No.
Are they all convex or concave? Okay. Are all the squares? Are they all concave? So, I'm going to give you a minute and I want you to do this quietly. All right, let's take a look at these then. So, puts us at Hayden. What would you classify A as? So we got equilateral and irregular. Okay, I can go with that. What about, let's see, for B? Let's see, 13, 15, 3, there we go. Jacob, what do you think? What would B be? Yeah, you. Okay. Yep. Absolutely correct. So if I take a look at the next one, what do we got now? Okay, so what do we got? Irregular, because that's all it is. We don't know anything about anything else. And so the last one there, Colton, what do we get there? Yeah. Okay, now I got a question for you. If I were to just say that it was regular, would that be enough? Or do I have to say that it's equal angular and equilateral? Yeah, because the definition of regular is that they are equal angular and they are equilateral, right? Okay. So, I'm going to give you a minute and I want you to think about these three. B, C, and D. Oh, not a problem. Okay, so let's give this some go. Oh, hold a sec, we have hope. We had an 11. So, is there a diagonal in GHJKL that contains points in the exterior? If I draw a diagonal, does it go on the outside? 50-50 shot, yes or no? Yeah, most definitely. If I take a look at the one that goes from here to here, it's on the outside, it's in the exterior, okay? So, if I've got that piece of information now and I look at this, Gavin, on C? What's it going to be? Convex or concave? Concave? You got the pictures drawn down? You're looking at them right now. And so it's concave. You sure? So, when you go back and you take a look at this, okay, convex, concave, right? And you say it's concave. Are you absolutely positively sure? Concave goes on the outside. I am trying to get you guys to be absolutely sure beyond the shadow of a doubt that if you got to go outside of it, it has to be what? Concave. Okay. Say what? Are they congruent? Why? Everything, corresponding parts are all the same, correct? Okay, so. Okay, give you a minute to think about that one. So, here we go. We don't have a 14. We don't have a 10. We've already done that. Well, since you're talking. So, what is 2? Interior or exterior? What is 2? 2 is exterior. What is 1? What? Absolutely correct. There you go. Now you got them. Okay. So, if I got to name the type of polygons used in this pattern, are the polygons regular or irregular? Regular. They would have to be in order to make this kind of a pattern, correct? Okay. Are any of the polygons going to be congruent? Would they all be congruent? Well, they'd have to be, right? I mean, there's no gaps between any of them that we can see. One side of one polygon looks like it's the side of the other polygon. So, are they going to be convex or concave? Convex. Okay. So, assignment is going to be due at the end of class tomorrow.